All right, well, welcome to the chain rule. We have one of the biggest rules to cover probably over the next 2 days. Um, if it doesn't click right away, I don't want you to get frustrated with yourself. We're going to practice a ton, and sometimes it just takes a little while for kids to see this chain rule in action. So let me talk through what the chain rule is. I'll give you the formal definition to start with here. If I want to take the derivative of f of g of x. Okay, I get f prime of g of x times g prime of x. All right, so what's the big deal about chain rule? Well, I want you to kind of highlight for yourself this function in here. Do you see how g of x is sitting inside of f of x? That is what makes it a chain rule. We have this thing called the inner function. Okay, this inner function g of x is inside f of x. So g of x is inside f of x. And that's what makes this a chain rule, when you have one function sitting inside of another. So the way I talk myself, we've had little sayings for things. The quotient rule was low d high minus high d low all over low squared. There's another saying for chain rule, and you'll probably want to write this down for yourself. It's derivative of the outside, keep the inside, times derivative of the inside. Which sounds like a mouthful, but once you say it a million times, you'll have it ingrained in your head. Derivative of the outside, keep the inside, times the derivative of the inside. So let me walk you through how the chain rule worked here. G of x is inside of f of x. So when I derive it, I'm taking the derivative of the outside. So my outside is f, so we called that f prime. We kept the inside. We didn't touch that inside g of x function. And then we did times. Now we took the derivative of the inside, times g prime of x. So we're going to walk through a bunch of examples and just kind of focus on deriving these. Before we do that, though, I just want to identify who is the inner function and who is the outer function. So maybe it's obvious, maybe it's not. There is somebody sitting inside of somebody else here. And to me, the parentheses kind of give it away. The parentheses tell you who is inside something. So let's copy this down and let's make a note about our inner function. The inner function, I'm going to call it f of x in this case. So my inner function is the 3x plus 5. And my outer function, which I'll just call g of x, is the x to the fourth, is the function being raised to the fourth power. So would you agree? We did composition in algebra too. So if I said g of f of x, that would mean take f of x and put it inside g of x. So I would substitute this into this. So g of f of x would be 3x plus 5 to the fourth. We actually did all this in algebra too. We just didn't take the derivative of it. Okay. Let's talk about this function. I'll just pick two different letters. Who is the inner function? Who's inside something? Is it obvious? The sine of x is in the square root. So I would say, I'm just going to pick different letters here. G of x is equal to the sine of x because it's in the square root. So my outer function, I'll just call h of x, just pick a different letter, would be the square root of x. And if I compose them, h of g of x would mean take your g of x and put it in h of x. Take this and put it in here. I would get the square root of the sine of x. How about this bear? Who's the inner function? Again, the parentheses I hope are a giveaway. Inside would be the 7x, and the outer function would be the sine of x. Oops, I'll just call this f of x and this g of x. So I would do g of f of x. I would put f of x inside there. So I would get the sine of 7x. So if you can identify the inner and outer, that's half the battle with chain rule, is just knowing what functions you're looking at, who is inside of another. So here, let's tackle a few examples. Number 1. And I'm going to start just by writing the derivative rule down again. The derivative of f of g of x is equal to the derivative of the outside, so the outside is f, keep the inside, times the derivative of the inside. All right, so who is inside and who is outside? Would you agree the inner function is the 3x plus 6, so I'm going to put an I there, and the outer function is the 4, so I'm going to put an O there. Okay, so the inner is just this linear function. The outer function, though, let's maybe make a little note, is a power. So we're literally just going to apply the power rule when we take that derivative. So watch how I derive this. I'm going to derive the outside, derivative of the outside. The outside is the power, so the power comes down in front. Keep the inside. Look at that phrase we wrote. Derivative of the outside, keep the inside. And when I do the power rule, the 4, we always subtract 1, so now that becomes a 3. Times, now derive the inside. If the inside was 3x plus 6, its derivative, 3x is linear, is just 3, and the 6 becomes a 0. As I clean this up, now just think order of operations. This cubed is only on this term. So you cannot multiply this 4 in here because this whole function would have to be cubed first. So the only things that I could multiply together are these two. So I'm going to say I get 12 times 3x plus 6 to the third power. And again, it's not possible for me to multiply this 12 in at all because I would have to multiply this out 3 times first, and they're never going to ask you to do that. You just leave this how it is. Let's try another similar example. H of x equals 2 times 3x plus 6 to the fourth power. So is the inside obvious to you? Can you tell me who is on the inside? Hopefully, you said 3x plus 6. Can you tell me who's on the outside? Hopefully you said 4. Now this is just a coefficient, this 2. It just stays there. It's not a times because there's no x with it. It's just a coefficient. So this is my outer. So let's go ahead and take the derivative. I want to derive the outside, so it's a power. The power comes down in front, which is going to get me 8. Keep the inside. The 4 becomes a 3 times the derivative of the inside. If the inside is 3x plus 6, that's linear, so that derivative is just 3. And then, of course, we'll clean it up. This cubed, I'm not going to actually do. I'm just going to multiply the coefficients. 8 times 3 is 24 times 3x plus 6 to the third. Okay, you can't pull a GCF or anything out of this because of that third power there. There's just nothing you can do. Just let it be. All right, let's tackle another one. And these are all going to be similar for this part of the lesson, and we'll get into a more complex one in the next lesson. All right, so identify the inside and outside. Now, just to be clear, maybe I overstepped in the beginning here. Why is this not power rule? To be power rule, remember, it can only be x to a number. This is way more than x, okay? And so was the previous one. So it's not just plain old power rule. There is an inside. So my inside is this function. My outside is this exponent. So f prime of x, I'm just going to say the phrase in my head, derivative of the outside. So the outside's a power, so the negative 2 comes down. Keep the inside. Always subtract your 1, so negative 2 minus 1 is negative 3. Times, now I need the derivative of the inside. All right, now I tried to mess with you a little bit with these e's and make you a little nervous and uncomfortable, and that's good. It's good to be out of your comfort zone. X to the e. Is e a number? Yes, we talked about Euler's number last year in Algebra 2. E is just a number. It's 2.718 something. So this is a power. It's the power rule because it's x to a number. So when I derive the inside, the x to the e becomes ex to the e minus 1 because I have to subtract 1. And e is just a constant, so its derivative is 0. Now when I go to kind of clean this up a little bit, again, this is being raised to a power, so I can't touch it. However, the power is negative, so I am going to move it to the denominator. x to the e plus e to the third. And the rest of this chunk I'm just going to leave on top. Negative 2 times e to the x to the e minus 1. And again, probably the best way to practice these is to, once you have them in your notes, before you attempt like the homework, maybe just practice them again in your notes so you can kind of follow it step by step. All right, number 4. Now you might be thinking, wow, this looks like a fraction. I'm going to jump to quotient rule right away. But that's not the case here. Because this has an inside, right? Because there's an inside, I know it's a chain rule. And that's what we have to kind of start looking for now. Do the functions have insides? So this definitely has an inside. So I'm going to first rewrite. Remember how we kept stressing that rewrite when we were doing the power rule? Let's rewrite f of x. We want to bring that up. So that's 5 times 4x squared plus 5x plus 2, all raised, if I bring it up, to the negative 5th power. Now, I hope it's obvious that you have this inner function and your outer function. Remember, this is just a coefficient. It just stays there. So let's apply the chain rule. So f prime of x, derive the outside, start on the outside, so bring that down. So you can do that in your head. That's negative 25. Keep the inside. Don't forget to subtract 1, so that's going to get you a negative 6, times the derivative of the inside. So now go to your inner function here and derive each piece. 4x squared becomes 8x. 5x is linear, so plus 5. 2 is a constant, so that becomes a 0. And then we just got to work on the calculus. So the cleanup. The calculus is just the chain rule part. The rest is kind of just your algebra. So let's call this f prime of x equals. Okay, so this has a negative exponent. It's telling me I need a fraction, and that's going downstairs. So 4x squared plus 5x plus 2 to the 6th. And then these guys are just going to stay on top, and I'm just going to keep that the way it is. Negative 25 times 8x plus 5. Okay. Could you multiply that through if you really wanted to? Yes, but you're probably fine just the way it is. All right, 5 is very similar to that one because, again, you'll notice you have a fraction, but there's not an x on the top and bottom. That's why quotient rule was out on the previous one as well. There's not x's there on both top and bottom. But what I want you to take note of is this 3 over 2. Okay, ignore the rest of the junk. If you just saw 3 on top and 2 on the bottom, again, let's practice rewriting. This function is really g of x equals 3 over 2. There's my fraction. And now this has to come upstairs. So times 4x squared minus 3x minus 1 raised to the negative 3rd. So again, before I think calculus, it's that rewrite step. Rewriting is key. Now we're ready to derive this function. Well, I guess once I identify the inner and the outer. And again, this is just the coefficient. It just stays there. So I'm going to bring this negative 3 down. Can you do that in your head yet? If I put a negative 3 here, obviously it's over 1. It's going to be a negative 9 halves. Keep the inside. Subtract your 1, so to the negative 4th, times the derivative of the inside. So this 4x squared becomes 8x. This is linear, so minus 3, and then the constant becomes 0. And lastly, we'll just kind of talk about that cleanup. Again, I have a negative exponent here, so that's going to tell me I need a fraction in my cleanup. So I'm going to move that to the bottom, this 4x squared minus 3x minus 1 to the 4th. I have negative 9 halves, so I'm going to leave the negative 9 on top, 2 on the bottom. Notice it's outside the parentheses. And then this 8x minus 3 stays on top. All right. 6, this is coming back again and again, right? The equation of the tangent line and the normal line. So again, anytime I see write the equation of a line, doesn't matter what it says, tangent, normal, whatever. Anytime you see line, you've got to be thinking, I need a point and a slope. Okay, and the point is your algebra, slope is your calculus. They always give you something, so here x equals 1. So we can go ahead and find the y value just by plugging in the 1. 2 times 1 is 2. 3 minus 2 is 1. 1 squared is 1, so I think we get 1. And now I need the slope, and again, that's where your calculus comes in. Slope means go and take its derivative. So go ahead and rewrite f of x for yourself. Okay, it's not a quotient rule because there's not an x on top. Just bring it up and rewrite it. So obviously there's a 1 as a coefficient, and I'm going to bring that up as a -2. Now again, it's not power rule because it's just not x to a number. It's an inside to a number. There's a whole function inside there. So let's apply that chain rule. Why don't you pause it, see if you can do the chain rule on your own, and then compare. So go ahead and pause it. All right, what do you think of my derivative here? I brought my -2 down, and then I subtracted 1, and the derivative of the inside 3 was a constant, so that disappeared, and -2x is linear, so times -2. And again, I'm going to rewrite it. This has a negative exponent, so that's going to the denominator. 3 minus 2x to the third. -2 times -2 is 4. So now I need the actual slope because the question was to write the equation of the tangent line at x equals 1. So now I need f prime of 1. So I have 4 over 3 minus 2 times 1 is 2 cubed. 3 minus 2 is 1. 1 cubed is 1. So I would say my slope is 4. So let me just put that tangent line together. My tangent line is y minus 1 equals 4 times x minus 1. And my normal line, remember, is just fancy for the word perpendicular, is y minus 1 equals -1/4 x minus 1, just opposite reciprocal. And we've answered that question. All right, last question here has 3 little parts to it. Each part is to identify f prime of 5. So we just need to take the derivative, and they gave us this key. Once we see these things on our paper, we can then substitute them in. So let's go ahead and find f prime. All right, so this says g of h of x. Do you see how h of x is inside g of x? So derivative of the outside. So it's not more memorizing that rule than that phrase. Derivative of the outside. So my g is outside, so that's g prime. Keep the inside times the derivative of the inside. So that would be h prime of x. Now let's just be really careful how we substitute things in here. So I have f prime of 5 equals, don't try to do anything in your head yet, g prime of h of 5 times h prime of 5. All right, so f prime of 5 equals, lots of baby steps here, g prime of h of 5. H of 5 is 5, so I have g prime of 5 times h prime of 5, which is -4. And then I'm going to go one more step. G prime of 5 is 6 times -4. I'm getting a -24. All right, let's try B. Who is the inside function and outside function? Excuse me. H of x is inside and the 2 is outside. So derivative of the outside, so that power comes down in front, keep the inside, raised to the first, times the derivative of the inside, h prime of x. And then again, we'll carefully substitute in 5 for all these. All right, so I need h of 5, which is 5, raised to the first is still 5, times h prime of 5, which is -4. 5 times 2 is 10, times -4, I think we get -40. All right, last one here. All right, this is not quotient rule because there is not an x on top, so I just need to rewrite this. So f of x is actually the quantity h of x raised to, right, this is really raised to the first. So to bring it up, I'm going to say raised to the negative first. So h of x raised to the negative first. Notice I put parentheses in there so I can clearly see this is my inside and this is my outside. So I'll go ahead and derive the derivative of the outside. Comes down, leave the inside, subtract my exponent, so now I get a negative 2, times the derivative of the inside, times h prime of x. Now, especially on this, before I plug in, because I have negative exponents, I want to rewrite before I dare plug a number in. Negative exponent moves to the denominator, so I have h of x squared downstairs. On top, I have negative 1 times h prime of x. And now I can carefully substitute in that 5 for myself. And I'm probably just going to write up here. So f prime of 5 is equal to negative 1 times h prime of 5, so times negative 4, just reading that table, all over h of 5, which is 5 squared. So it looks like I get positive 4 over 25. All right, so that does it for chain rule 1. Take your time. Please don't stress out if it was a little tough. We're going to get a lot more practice.